HVAC sizing for design build pricing can be estimated using simplified formulas, particularly useful when dealing with empty shells. These formulas offer a quick way to approximate the required AC and heating capacity. For residential buildings, the air conditioning capacity in tons can be estimated by multiplying the floor area in square feet by 0.8. The heater capacity in British thermal units per hour, or beta, is calculated by multiplying the floor area in square feet by 10. For commercial buildings, the air conditioning capacity in tons is determined by multiplying the floor area in square feet by 0.1. The heater capacity in British thermal units per hour is calculated by multiplying the floor area in square feet by 20. Let's consider an example. Suppose we have a residential building with a floor area of 2,000 square feet. To calculate the AC capacity, we multiply 2,000 square feet by 0.8, which equals 16 tons. To determine the heater capacity, we multiply 2,000 square feet by 10, which equals 20,000 British thermal units per hour. Keep in mind that this formula provides a rough estimate for sizing HVAC units. Actual sizing can vary based on several factors. Firstly, climate plays a significant role. Regions with hotter summers will require larger AC units, while colder climates necessitate more powerful heating systems. Secondly, building orientation affects the amount of sunlight the building receives, impacting heating and cooling loads. Buildings facing south tend to have high cooling loads in the summer, while those facing north may require more heating in the winter. Thirdly, occupancy levels influence the internal heat gain. Buildings with higher occupancy rates, such as offices or schools, will generate more heat from people and equipment, requiring larger cooling capacities. It's highly recommended to consult with an HVAC professional for detailed load calculation. Professionals use specialized software and consider all relevant factors to determine the precise HVAC requirements for a building. Furthermore, the formulas presented assume a standard ceiling height of 8 feet. For buildings with higher ceilings, adjust the capacity accordingly. Higher ceilings increase the volume of air that needs to be heated or cooled, thus requiring larger HVAC units. As a rule of thumb, increase the capacity proportionally to the increase in ceiling height. It is also advisable to add a factor of 20% to account for a safety margin and future expansion. This buffer ensures that the HVAC system can adequately handle peak loads and accommodate any future increases in occupancy or equipment. In summary, use these simplified formulas as a starting point for estimating HVAC sizing and design build pricing. Remember to consider the influence of climate, building orientation, occupancy, and ceiling height. Always consult with an HVAC professional for a detailed load calculation to ensure accurate and efficient HVAC system design.